Okay, wanted to finish off our lesson from class today with a discussion on a couple of things here. The first being whether or not a function is increasing, decreasing, or constant, and how to answer that question. So we look at this function here, we'll call it f of x, and let me change my color there. So this is f of x, and I can see from this that if I'm reading left to right, worrying only about the x variable when we talk about this. We're worried about the x variable. So if I read left to right, we're decreasing right there. And we're also decreasing right there. And because all of these are solid dots, then they're going to include our endpoints of our intervals. So for decreasing, I'm going to say we're going to start right here at -6 and include it, and go to right there, -4, looking at our x values. Again, left to right is a horizontal direction, so we're going to work with the horizontal variables. So that's one of our ranges. The other one is over here to here. So there we got including 3 to 6. Okay? 3, 6 is not a point, it's the range between 3 and 6. Okay? So that's decreasing. Then to do increasing, we go here. We say, all right, well, we start here and we work our way up, right there. So the graph is increasing right to there. And again, we work with our x and x variables only as we read left to right to create our range. So what we're looking at is we're saying the y values are increasing between certain x values. So again, this range is right here to right here, including them. So we've got -4 to 0. And that seems to be our only increasing scenario here. Now our constant is in red here. So our constant, the y values don't change at all. In other words, the rate of change doesn't change at all. It's constant. So we go back to black. Oh no, I'll keep it in red. And we work from 0 to 3. And now you've covered the entire thing. If I were to write the domain of this function, the domain would be from -6 to 6, and my range, oops, let's erase that. My range would be, excuse me, from -2 to +4, and including those 4. Okay? Alright. Okay, so now we're going to look at rate of change, and this was the last goal that we didn't really get to too thoroughly today, and so wanted to talk about it. Rate of change. It's basically the change in your vertical over the change in your horizontal. So it's kind of like slope, but it's not slope because slope only pertains to lines. And especially when we look at other polynomials and things that aren't lines, we can't call it slope, we can only call it the rate that it's changing. So certain areas of the polynomial might have a slower rate of change, meaning a more horizontal looking line, versus a steeper line that would have a really high rate of change. So for this particular guy right here, we're going to look at where x equals 1, between that and x equals 3. Okay, so we're looking, when we say change of 1 to 3, we're talking x values specifically. So our formula is right here, and the change in y is sort of like what we used to do with slope, where it was y2 minus y1. Well, we sort of do the same thing here. We start with our x values, and we say, all right, well, we're going to go out to x and back to c. Okay, so out to x and back to c. So in this case, I'm labeling 3 as x and 1 is c. So my change in y is going to equal f of 3 minus f of 1 all over 3 minus 1, my x values, my x minus c, which is my change in x. Alright, so f of 3 in this case is 3 times 3 squared minus 3 times 1 squared, all over 3 minus 1. So I end up with 9 times 3 is 27 minus 3 over 2. So that equals 24 over 2, which equals 12. So our average rate of change is 12. And then, if it had units, you would consider the units. But sort of our speed or our average rate of change between x values 1 and 3, so our rate of change along here is 12, average. Now we've got one from 1 to 7. Same thing, delta y over delta x, f of 7 minus f of 1 over 7 minus 1. So we end up with 3 times 7 squared minus 3 times 1 squared, all over 7 minus 1. So we end up 3 times 49, which is 120, 147. Excuse me, let me erase that. 147 minus 3 over 6, which equals 144 over 6, which equals 72 over 3, which equals 72 over 3, 24. So our average rate of change from 1 to 7 is 24. Notice that we've doubled our rate of change. And that has to do with the fact that this function of x, is squared. And so our rate of change is ever increasing as we go up and up and up in x values. Okay, hope that helps. Thanks.